so let's talk about this warm-up. So, you had the question, what is the meaning of this data set? And then you had this data set of 9 or 10 numbers. So, to start off with, thinking back to earlier math classes we've taken in the past, what does the median represent of the data set? What is the median? Landon?
It's like the medium number.
The middle number. All right, let's stop that, please.
Dylan. Liar.
So the median, that's your middle number. How do we find the middle number on the data set? Actually,
Is it where you add everything up and then
The middle number.
No, oh, but the
Middle number.
so you're thinking of the mean. So if I want to find the middle number of this data set, do I need to do anything to it first?
Yeah.
What do I need to do?
You need to put it in
Order. I need to put it in order from least to greatest.
Oh.
So we need to rearrange this data set before we can find the median. So I'm going to start with my lowest number, 9, and then I go to
11, 12,
12,
14, 18, 26.
7, 12.
7,
7.
2,
Potato.
All right, so when finding the median, the first thing you want to do is arrange that data set in order.
It's 12. 12.
Now from here, we can start figuring out what is the middle.
It's 12.
So one way of going about this is you can count all of the numbers and divide it in half and figure out what the middle is that way. Or you can cut ends off. Cut one off from each side continually, back and forth until you're left with that middle number. So 12 is our median. Are we okay with this? Does this seem familiar from previous math? All right. So, try it one more time. I put the numbers in order for you to make it easy. See if you can find the median of this data set to start off with. All right, we need to pump down 5. So I'm glad you can find the number, but we don't need to shout it out like that, please. All right, let's focus. I know it's Monday, but we need to pay attention, please.
Word. Shout out to
So once again, you can cut off each end
0.5.
until you're left with the middle.
What happens if it's an even number?
Like,
All right, great question, Bradley. Let's talk about that. So what happens if it's an even number? What happens if we have an even number of data sets and we keep cutting it off and we have 2 numbers left in the middle? Let's say 23 and 24 or whatever it is.
23.5.
Yeah.
20. So if you have this as an example, say you are cutting off from both ends and you're left with 2 numbers in the middle. You need to find what is in between both of those numbers. So the way you can do this is you might be able to think, what's the middle number between them? Or you can add them together and divide by 2. And that will also give you... How are we doing? So either of those methods might work. So that's in case you come into contact with 2 numbers in the middle. So we found the median of this data set to be 25. With what we're going to learn today, we're also going to need to learn how to find the median of the lower half of this data set and the median of the upper half of this data set. We're going to call these quartiles, and we'll talk about them in a moment. But if you were to find the median of just this lower half of the data set, what would you do? 22. So if we were to cut off from each side, we have 20 and 23, and we're left with 22 and 22, so that gives us 22. Looking at our upper half of our data set, cut off from each end, we have 28 and 29. So just like what we just showed over here, we can go right in between them and go with 28.25. So our median of our lower half of our data set, this is going to be 22, and our median of our upper half of our data set, that is 28.5. All right, boys, keep your hand to yourself.
Yeah, I didn't do anything.
I saw it.
Ladies, ladies.
Okay, let's listen. Boys in the back, let me do too. So, the reason we want to learn how to find the median and be able to find the median of the upper and lower half of the data set is because we're going to use these to talk about box plots. Have we learned about box plots in earlier math classes?
Yes.
I think you may have, so some of this might be review, some of it might be new, that's okay. So let's talk about a box plot. So what a box plot is, it's a way that we can organize data, and it's a graph that helps us show the distribution of the data set. So distribution, that means how wide or how spread out that data set. How is the data spread and how is it distributed among the number set. And so, by putting this information into a box plot, by looking for specific pieces of information from the data and putting it into a box plot, we can interpret what the spread of the data is and where are the majority of the data pieces. So a box plot splits our data up into 4 pieces. There are 4 main parts. We have what we call the first quartile, we have the second quartile, the third quartile, and the fourth quartile. We split up into 4 pieces. We use that word quartile. That represents, it's like the word quarter. It has a key, that's not a letter. Q-U-A-R-T, that quarter, which means a fourth. And so we're splitting up into 4 sections. And depending on how large these sections are, can help us determine how large our spread of data is in each of those sections. It can help us determine where the majority of our data falls from a data set. And so we have a couple special points that we need to use to be able to split up our data into 4 pieces. We'll need to figure out what is the lowest value, what is the lower quartile number, which we'll talk about, what is the median, what is the upper quartile number, and then what is the highest value. So we need these 5 pieces of information in order to create our box plot, or box and whisker plot, as we like to call it with the little whiskers on the side. So we need these 5 pieces of information to be able to create these box and whisker plots, which can help us determine this data. So once again, these are the 5 pieces of information now. We have that minimum value, the lower quartile, the median, the upper quartile, and then the maximum value. So the minimum value, pretty easy to determine. It's just going to be what is the smallest number of your data. Smallest number. Now the lower and upper quartile, we'll talk about those in a sec. But in order to first find the lower upper quartile, you first need to know, I guess I'll talk about the maximum. So maximum value is just like the minimum value, that's also your largest number. We'll get that out of the way too. So the largest number in your data set, smallest number in your data set. Your upper and your lower quartile. In order to find these, you first need to figure out what your median is. So once again, that's your middle number, like we just practiced on the warm-up. So once you get that middle number, once you get that median, you can take that out of your data set, and you're left with 2 halves of our data. Just like what we had on that last problem. We had 2 halves of our data. We had that upper half and that lower half of our data. If you can find the median of each of those halves of your data, those will be your upper and your lower quartiles. So for our lower quartile, we'll find the median of the lower half of our data. And then for your upper quartile, that will be the median of the upper half of your data, or the larger half of your data. So if you can find these 5 numbers, so each of these will be a number, we can set them on a number line, and we can then draw our box plot from there, and that can help us determine what is the spread of this data. So let's practice making one of these. So we have 9 or so points of data. we have a number line on the bottom. We're going to make our box plot on this. So once again, we need 5 pieces of information. We need the minimum value. We need the lower quartile. We need the median, the upper quartile, and then we need the maximum number. Are there any of these that you know right away? Wyatt? What was that? Good. So before we can start figuring out what some of these are, it's probably easiest to order them from large to small. So put those numbers in order. So our smallest number we start with is 3. And then we have 5, 6, another 6. From there we go up to 8, then 9, and then we have 2 10s, and then our last number is 13. So by ordering this number in that data set, by ordering it from lowest to smallest, it'll make it easier to find some of that information. So what is our smallest number? What is our minimum value? 3. What is our maximum value? 13. So our data set goes from 3 to 13. Now from here, we'll want to be able to figure out what is your median of your data set. So figure out that minimum, figure out that maximum. Now we need to find the median. So once again, for median, start cutting off from each end until you're left with that middle number.
8.
8.
8. It's 8.
No,
Oh!
So we have 8. Now, once you get your median, in order to find your middle or your lower quartile and your upper quartile, we're going to do that median thing again, except we're going to focus on what is the median of your lower half of data for your lower quartile, and what is the median of your upper half of data for your upper quartile. So if we were to find the median of the lower half of data, we see we can cut off from each end, and we have between 5 and 6. That's 5.5. Same thing for your upper quartile. We need to figure out what's in the middle. And so we have 10 and 10, so our middle number is just 10. Once again, if you have trouble figuring out what is that middle number, add them 2 together, divide by 2, and that will give you that value for that middle number. So if you got 5 and 6, add it together, you get 11, divided by 2 is 5.5. So we have all 5 pieces of data. So we have all 5 pieces of data. Now we need to focus on drawing and creating this box plot. So before you can create this box plot, we need to put numbers on our number line. So my data, I know it goes from 3 to 13. So I need to make sure I can go from 3 to 13 on this number line. So let's see. I'm going to start with 0, and I'm going to go up by, let's say, 3s all the way to 15. That should be enough. I guess I don't use my whole data set, but I probably could have used a smaller value, but that's okay. So I'm going up from 0 to 15 on my number line. I probably could have gone up by 2, but that's okay. It doesn't really matter just how wide our data spread. Now, using our information, we want to plot those points on our data set. So my minimum value, that's 3. My lower quartile, 5.5. My median is 8. My upper quartile is 10. And then my maximum value is 13. So for creating our box plot, the way we go about this, you want to create the boxes with your upper and lower quartiles and your median through the center of them. So we have our upper and lower quartile. You're going to create your box with those 2 lines. So from my 5.5 to my 10, that's where my box is. My median is going to be a line inside that box. The whiskers of your box, those are going to be your minimum and your maximum values. So from your box, you can draw a line over to your minimum and maximum values, and those will be the whiskers of your box plot. And from here, you have constructed your box plot. I know some people like to write the values above the numbers or below on the number line to represent what those numbers are. So you might want to write 3 and 5.5 and 8, 10, and 13. You can do that. That's good. But as long as you have this information along with it, that also tells you information. And that is how you can create a box plot. And from there, we'll talk about how to read that box plot, interpret the data, and determine those values. Do we have any questions over creating the box plot at the moment on what we just did during this problem? Seems pretty easy. Seems familiar from stuff we've done in the past. All right. See if you can create a box plot for this data set. So you have the data set, put it in order, find your minimum, your lower quartile, your median, your upper quartile, and your maximum. Create your number line, and then plot your points. And see if you can create that box plot. All right, let's listen up. So by now you should have this information. So if your lower and upper quartiles are off, my assumption would be when you got to those middle two numbers of 49 and 50 to get your 49.5 as your median. If you got a different number for your lower and upper quartile, it's probably because you didn't include 49 or 50 in those lower ranges. So if you have a middle number in between those two, so if your number is not one of those two, when calculating your lower half, when calculating the median of your lower half, you will include 49. When calculating the median of your upper half, you will include 50. If one of those numbers were your median, though, you would not need to include it in either the lower or upper half. It's only when it's split into two that you need to include that in the lower half and include that in the upper half. So from there, we end up with 50 and 52 as our upper and lower quartiles, because we're including that 49 and 50 in those upper and lower halves. From here, we can then go on to creating our box plot. So there's different ways depending on what scale you use for your box plot. Might depend on or might change the shape of it. I'm going to go from, let's see, what did I use? So I'm going to go from 40 to 40. All right, so for my box plot. All right, for my box plot, I went from 40 to 62, just because those are my points I had. I went up by twos. I know from 40 to 62, it incorporates every piece of data I have. It incorporates my minimum to my maximum, and it goes up by a nice, easy scale that I'm good to see. So from here, I need to put on my main points, my specific points that I got. So I found my minimum was 43. So I need to find 43. I'm going to put a little tick mark. I'm going to find 48. I'm going to put another tick mark. Ooh.
There's the numbers.
Then I can go to 49 and a half. Yeah. 52. And then 57. So these are my main data points that I want to focus on for my box plot.
Great job, Charlie.
All right, let's stop.
You get a gold score.
So, in order to create the box plot, you are going to get those three middle lines, and that is going to be your box. The middle line will be a straight vertical line somewhere in that box. but your lower and upper quartile numbers, those are what's going to create your box. Your whiskers of your box plot, those are going to be from your box all the way to your minimum and your maximum value. Those are the whiskers of your box plot. Are we okay with this? Do we feel okay on our steps? Were we able to get this?
Yeah.
All right. So being able to create the box plot is one thing, but also we want to learn how to be able to interpret the box plot. What is it saying? What does these numbers mean? Why do we put this number in this data set? Or why do we why do we put this number like this? How does that help us interpret it?
So we can learn.
So here are some ways that we can interpret a box plot. Here are some things that you might look for when looking at a box plot. So once again, the box plot shows the data spread. It helps us visualize what the spread of the data is, and it can help us answer a few questions. It's more than just looking at what are those numeric numbers. What is the median? What is the lower quartile? What is the upper quartile? Those are important numbers to know, but our box plot helps us visualize data besides just looking at those values. So for example, it helps us figure out where is the median from your minimum to your maximum value. Where does that median fall? Is it closer to your minimum? Is it closer to your maximum? Where is the middle 50% of your data? That box in the middle, that represents 50% of your data, and that represents the middle 50%. The average 50% of your data is all going to fall within that middle half of your box plot. So this middle part determines where the majority of your data will fall, where the majority average will fall of your data. How wide the spread is of your data. So each of those quartiles, they're a different size, from that lower quartile to the upper quartile. They represent different sizes. The wider the quartile means the larger the spread. The closer the quartile, the smaller the quartile, that means the closer those numbers are together. Each of those represents 25% of your data. So 25% of your data falls within each of those quartiles. If you have a smaller quartile, that means 25% of your data is very close together. Well, if you have a wide quartile, that means 25% of your data is very spread out, very far apart. So once again, is one quartile wider than another? Do you have a larger lower quartile than a larger upper quartile? And then, do your whiskers show any outliers? What does the word outlier mean?
Something away from.
Something away from something. So an outlier represents a number that's not with the rest of the group. So if you have a number in your data set that stands out, that's very far away from the rest of your group. For example, if you have a bunch of numbers in the 20s, and then all of a sudden you get one other number that's in the 40s, that number is an outlier. Any number that is very far away from the rest of the group, that's very spread out from the others, that's called an outlier. In your whiskers, if you have an outlier, your whiskers will show them. If your whisker is really, really far away, and you're really, really spread out, that shows an outlier. And these outliers, we can determine to take them out of your data set to make some changes. And we'll talk about that later in the week, how outliers change your data and how you can take them out of your data to fix it. But your whiskers of your data set can show the outliers. So we're going to look at an example of this. So I have 4 box plots here. They're vertical rather than horizontal. It doesn't matter which way you make your box plot. You can make it go up and down. You can make it go left or right. It doesn't really change it. You can still read the data. So we're going to try to determine a couple of things based off of this data. So based off of these 4 box plots, which of those box plots has the widest spread of data? Which one has the widest spread of data?
3.
3. Boys, you need to calm down.
Calm down.
So if we look from the minimum value to the maximum value, our third box plot has the widest range. It has the widest spread of data. You can look because your minimum value is the lowest and its maximum value is the highest. And it's the farthest spread apart. It's the widest data. So which box plot has the lowest median? 2. What was that, Dominic? 4. 2. How do you know it's 4? It's the lowest. Oh, so if we look, that median represents that middle number inside your box plot. So our fourth one has a median that's way down here compared to our other ones, which are all the way up around 270. So 4 would be the box plot with the lowest median. So this tells us the data set from 4 is much lower on average compared to our data sets from 1, 2, and 3. Which box plot has the closest spread of data? 2. If we look, 2 is very close together. It's very small, it's very shrunk. And so because it's so close together and because it's so small, this determines that all of those numbers in that data set are very close together. They're very close apart. They're not spread out like some of our other data sets. We don't have data sets going from all the way up to 350 all the way down to 250. Our second box plot is only from about 300 to 250-ish. So it's very close together with that data set compared to the other ones. And now if we look at 1, our box plot for 1 seems kind of normal, except what do you notice about that whisker?
Longer than the other one.
What do you think could make that whisker so long?
That's a large range of numbers.
It could have a large range of numbers. Another thing that could also make this whisker so long, boys, listen up. Another thing that could also make this whisker so long at the top of 4 or at the top of 1 is it could have an outlier. So all the other numbers are pretty close together with their whiskers, pretty average, but 4 or 1 has that whisker that goes way out top. So there might be a number, for example, it might be 350 way up here, but then all the other numbers might fall somewhere down in here for a more typical whisker. Also, depending on the size of each of these, tells you how much spread is into each of those box plots. So for example, 25% of the numbers fall in here, while 25% of the numbers fall in here. So you can see that this upper quartile is much closer together than this upper whisker range, that 4th quartile. We're going to practice this and talk about it more tomorrow. We're going to look at some data and be able to create some box plots and interpret what they mean tomorrow.